Good afternoon, class. Welcome to Section 3, Searching for and Evaluating Oil and Gas. Learning objectives for the week. We're going to explain how to obtain the rights to explore for and produce oil and gas. More so with the production sharing agreements. We're going to talk about more about that than anything else this week. And also we will talk about drilling, exploration, and surveys, and how that all ties in with the country who wants to get the resources to market. Key terms for the week. There's a shed load of them here. I am not going to read them to you, and I'm going to jump right into the lectures. So we're going to talk about mostly production sharing agreements and how that works. And I'm going to tell it as a story throughout the next couple of slides, and hopefully you'll better understand it that way. So let's say that I'm a small country. Let's say I'm Brunei. I'm over there just north of Borneo, and I don't know that I have oil in the ground or gas in the ground, but oil majors have been probing around the area, and they have a rough idea that potentially there could be hydrocarbons in the ground, maybe offshore of my country. All right, and let's give you my little scenario. And this happened back in 1970s, and I'll just tell the story how it progresses, and hopefully you'll understand production sharing agreements better that way and how the whole system works. So oil majors, they know where oil is to on the planet. Well, they have a rough idea. They know that certain rock formations give you certain types of oil. I remember I bumped into a guy at Memorial University, and he said the oil and gas formations here off Newfoundland are the same rocks off the coast of Morocco. And he said in 10 or 15 years, guaranteed the same exploration is going to be off Morocco because the same rock formations are there, and guaranteed there's going to be oil there. So they have a rough idea of the picture of the rocks around the planet, and because of that, they have a rough idea where everything's happening. So I'll use Brunei as an example. Shell, BP, I think Exxon as well. They had a rough idea that there could be possible hydrocarbons in and around Brunei, and they started wang dangling, I guess, the country and said, look, we'd like to start looking for oil or gas around your place. So they put in their contracts or their bids to start just basic survey work. And so the country has a ministry that deals with their natural resources, and the ministry assigns the contracts. In this particular case, Shell won that contract. So for those of you who don't know, production sharing agreements are among the most common types of contract arrangements for petroleum exploration. And terms you need to know are either an FOC or an IOC, which is a foreign oil company or an international oil company, and usually it's an oil major. Okay, and then there's also the government or the ministry, and then there is, and depending on the government and how complex it is, it might actually have its own national oil company. In the beginning of this, there was no oil in Brunei at the time, in 1970s, and they just had their ministry, and the foreign oil company, which was Shell, or the IOC, which was Shell, came in and they started up a production sharing agreement with the country. And the production sharing agreement is usually heavily favored towards the country because they have the resources. And the IOC, or the foreign oil companies, have the technical expertise to get it all out. So it is pretty a standard contract, and there are different things about it we'll talk about as we get onto it. But that's how it's going to start off first. So I'll use IOC for most of my conversations. So the International Oil Company is going to approach the country and say, let's have a production sharing agreement, and this is how it will work. The main distinguishing features of the production sharing agreement are 2 points. Number one, the IOCs, the oil majors or the international oil companies, however you want to call them, if they come in and bear all the risks to locate and find the oil. So the survey work they do, bring in boats to do the seismic. Once the seismic's done, they think they have a good chance of finding it, then they'll bring in a drill ship or a drill rig to actually drill to get down to the oil. And if they don't find anything after all the end of that, all the risk that they took to invest to find that oil and they didn't find anything, all that financial risk is borne on them. So the country itself doesn't pay a dime now. So if they do find oil, they will be reimbursed. And we'll get into that later on. And the second part of that is once they do find oil, all the hardware that they implement after the fact, so the pipeline getting it ashore, the refineries, the plants, maybe a jetty, shipping, all right, for all that. Maybe not the ships themselves, but all the hardware, the resources for the installations is usually all owned by the government as well. I have jumped ahead many slides here now to slide 16, but I love using this slide to explain this topic because it kind of summarizes everything that we have in one picture. All right. So we talked about it already. I'll be the contractor in this particular case, and I've approached the government saying, government of Brunei, that possibly you could have oil or gas in your ground, possibly offshore. And so I'm the contractor. I have all the technical skills and knowledge to get that out of the ground, and most governments do not. They might have a national oil company, but in this particular case, they do not. So the contractor bears all the cost to search for and locate these resources in the ground. And there's also smaller clauses and contracts in there as well. They might have a contract to say, I will survey this area, and then once they survey the area and they find it, then they might go to the country and say, okay, we have positive results. Now we'd like to have a contract for drilling 2 or 3 wells, and those kind of things are in there. So if I am the contractor, I'm the international oil company that comes in, and I do my seismic work. I bring in my boats. They're pinging the bottom of the ocean. They're painting a picture of the substrata in the Earth's crust, and they locate. They think they have oil. They go to the government and say, look, I think I have something here now. I'd like to have a contract for drilling to confirm. And then I, as the contractor, I have either my own rigs or I subcontract rigs out, and we drill, and lo and behold, voila, we find oil. Perfect. So that's lovely. Let us say we did all that though, and we didn't find anything. We drilled a well, and it was dry. All the expenses that I took to get the seismic, hire my geologist, hire the drill rig, it could have cost me millions, possibly billions of dollars. It might be a bit far-fetched, but it's a lot of money. But if I didn't find anything, all those costs, the risk of that exploration is borne on me. So if I don't find anything, the country doesn't pay anything. They go, thank you very much, and that's it. And I'm out so many millions of dollars, and that's it. But in this particular case, I have found oil, and I've also worked with the government, and we have pipelines installed, a plant and refinery, and now we're at the stage where we are going to sell the oil. All right. So let us use in our example here that we're going to sell the oil at $20 a barrel. I know it's a little low, but it's just a nice arbitrary number that I've picked. And so we are going to sell the oil to market, and the contractor, the oil major, has got connections to sell the oil on behalf of the government, and they write up the contracts for all that, and we're selling the oil at $20 a barrel. So before we sell anything, the government takes their cut, also referred to as royalties. Usually around 10%, 12, 9, whatever the agreement is. It can fluctuate. But I want to point out that it's all before any taxes come out, any of the cost oil or any of the profit oil. So as soon as the $20 is being sold, the first 10% goes straight back to the government. All right? So out of your $20, you are left with $18. Remember I told you that the contractor itself bears all the cost for the exploration. So what happens is, at this stage here, that $18, there's a thing called cost oil. The percentage itself can fluctuate. It very rarely ever exceeds 50%. It's usually 33% ballpark. And that third of the $18 goes directly back first to reimburse the contractor for all the time and expertise it took to find the oil. So it pays off for the surveys, the seismic work, the drilling, all that is paid off. So at this stage, I know it says the contractor gets $6, but really he's only breaking even because all that money was spent ahead of time, and now he's just being reimbursed, so now he's at $0. And that is referred to as the cost oil, and that is split, 1/3 goes to them, and that's fine. So the other 2/3 comes down here, so it's $12. And this is referred to as the profit oil. And now we're actually starting to sell the oil to market. So the profit oil is usually split mostly in the favor of the government. It's never ever 50-50, so it's 60-40 or whatever it is, 70-30. That's all the contract details, and we're not going to get into that. I used 60-40 for my example. So 40% of the profit oil goes to the contractor, the IOCs, and the other 60% goes to the government. The great thing about the profit oil is anything oil coming out of the ground and the contractor wants to sell, he has to pay taxes back to the government. So in this particular case, he's a 30% tax on his $4.80, and that takes right out of the contractor and goes directly over to the government, and that's lovely. And then there's the gross revenue. So the gross revenue takes into effect the $6 they've earned here, the $4 they get from the profit oil, minus the taxes, and come with 936. But 936 is a bit of a false number. It's the gross revenue, because remember, the $6, they spent all that $6 before. So that $6 gives them the break-even mark. So for every barrel spent, they're only netting $3.63 per barrel, while the government, on the other hand, is making $2 from their royalties. They're making $7.20 from their profit oil. They're getting $1.44 from their taxes, which comes up to a gross revenue of $10.44, and their net cash flow of $10.44. So they're making just a little bit more than half of the barrel of oil goes to the government, and a smaller fraction here goes to the contractor. So if you talk to these guys who are talking about the production service agreements and contracts and stuff, they usually say it's a 25-75 split, usually. And that's how it normally works out at the end of the day. They're making 25% on every barrel spent, and the government is making 76%. The cost oil up here, I have talked to many company men over the years and stuff like that. The cost oil, because all the money is going directly in here to pay for that, the contractor usually makes back his money for all the exploration in the first 7 to 10 days of the well, because most of the money goes directly to reimburse the contractor. So that works out well as well. Fair enough? There you go. Hopefully that explained it so you actually understand what's going on. When the IOCs, with their geologists and their knowledge of the Earth's crust, approach a country because they suspect that there's hydrocarbons in or around their territorial seas or land, the first contract they usually sign up for is the exploration rights and negotiate that through what kind of systems they're going to use. Nowadays, they're using 3D seismic and 4D seismic and satellite imagery. It's all very, very high tech. Hence, when you're drilling a well these days, I think it has risen now from it used to be 75% success rate. Now I think it's something like 60 or 75% success rate, because these guys really know where the stuff is too. In the old days, and I have a little clip here of the Beverly Hillbillies, they used to look for seepage at the other end of the reservoir rock. So the reservoir was here trapped, but here at the surface there'd be seepage. And when Judd Clampett shoots his gun, poof, he hits a section of the seepage, and all of a sudden he's an instant millionaire. And here's that clip now.
Come and listen to my story about a man named Jed. A poor mountaineer barely kept his family fed. And then one day he was shooting at some food, and up through the ground come a bubbling crude. Oil, that is, black gold, Texas tea.
So we said that the IOCs, international oil companies, they know roughly where oil is or what conditions it should be found under. But it's not just the conditions. So we talked about it in chapter 1 of how it's made, using pressure and temperature. But you also need the right trap to hold it, and the reservoir rock and the permeability and stuff like that. So it's a whole bunch of array of things that they're trying to find. So the geologist and we use seismic here now as my example, and we're going to use a marine environment. You can use it on land as well. They use trucks on land and they pound the ground for the vibrations. But at sea, we'll talk about this a little bit later on. We're going to use seismic boats, and they're going to use their sonar to go up and down, back and forth, and they're mapping out the strata of the rock to find out if the right conditions or a trap is there to hold the reservoir. Okay, and that's what we're going to be talking about next. There's all kinds of technology out there for exploration activities. Number one is satellite imagery, and used more so on land, as you can imagine, than at sea. We can measure how the flow of hydrocarbons affects gravity, so we can use gravity meters. What else? Magnetometers, which measures the tiny changes in the Earth's magnetic field due to the cause of the flow of oil. What else do we have? The nose sniffers. They can smell hydrocarbons. They have these great little devices. But the most we're going to use this term is seismology. And that is, and we're going to talk more about it from a marine point of view. It can be used on board on land. They use trucks that reverberate and shake the Earth's crust. They have these little thumpers on the trucks and shake the Earth, and then they get the pictures back. But we're going to use ships on board in our example here, where an air cannon is shot out from behind the vessel underwater. That noise travels through the Earth's crust and reflected back and is picked up by sensors, and then they paint a picture of the Earth's crust to find out what's down there. Exploration activities are very, very important. All right? There's a huge financial risk if you drill and find a dry well. All right? So nowadays, there is a huge amount of technology used to make sure they know what's in the ground before they start drilling. And seismic surveys can save companies hundreds of millions of dollars if they give them precise information, show them where the cap is, the deepest part of the reservoir, how big it is. They also use 4D models so they can see flow within the reservoir, and it is very, very important that they get an accurate picture before they even start drilling. And like I said, if you find we talked about it earlier on in the PSAs, if you go up and drill and find a dry well, then that's it. All the financial burdens are all on you, and that can cost you millions and millions of dollars. For those of you who are not familiar with seismic vessels, they are purpose-built ships specifically for seismic work. You can see in the picture below, they are dragging streamers behind, and the streamers are the sensors which pick up the echo from the air cannon that is shot below. And the sensors are hooked to a supercomputer, and when the reverberations come back to the sensors, the information is sent to the supercomputer, and the supercomputer then paints a picture of the Earth's crust below and where the hydrocarbons are, if any. The great thing about seismic vessels and streamers are they are able to cover a huge amount of ground quite quickly. These streamers are, I don't know, it looks like a small distance there, but those streamers, they drag behind the vessels about a mile or so, and they're quite a wide spread. And out here in the far corners, they have small boats that keep other vessels away, and chase boats they're referred to. And the boat goes up and down a grid pattern and takes a picture of the Earth's crust. They are very, very cost effective. I make it sound quite easy. You know, you have a seismic pulse that is reverberated through the water. It's reflected back on the subsurface formations and comes back and is picked up by the sensors and then goes to the computer. And then voila, they paint a picture of the Earth's crust and substrata. It is a little more complicated than that, as you can imagine. I'll even start off with the terminology. I'll use the word sensors quite a bit. They're actually referred to as geophones. So the geophones are on the streamers, and they pick up the reverberations back from the seismic pulse. And as you can imagine, this becomes quite complicated when there's hundreds or thousands of feet of water between the Earth's surface and the geophones. And like I said, a supercomputer is used. Once they collect the data, even then, after that, it takes about 2 years for that supercomputer to transfer all that information into a picture, a usable picture, to find out what is there. Here is a cross-sectional picture of how seismic works in a very simple mode. Here you have the air cannon or air gun, which sends off the seismic pulse. The pulse is then sent through the water and transfers through the Earth's crust. At certain points it reflects and is bounced back and is picked up by the geophones on the streamers. And that information is all sent back to the vessel where it is collected on the supercomputer. And then when it's brought ashore, it is transferred into a 3D map of the area. Despite all the high-tech seismic work, the only way to truly know if there's oil in the reservoir is to drill a well. So going back to our contracts, you've just done the seismic contract for exploration, and you think you have a really good chance, you have 95% chance or whatever it is that there's oil in the ground. So you bring that information to the hosting government, say that this was successful, and the next stage in the development is to drill an exploratory well to find out if there's actual oil in the ground. There are many different technologies for this, which we're going to talk about in a few minutes, but that is the only way to truly find out if there's oil in the ground, is to drill a well. We're not going to go through too much detail for these particular types here. There are hundreds of different types of evaluation methods used for when you're drilling. These are some of the main ones, and if you worked on a drill rig, I'm sure some of these are very, very familiar with you. We use mud while drilling. It's used to lubricate the drill bit, but also to keep the well from crashing in on itself, and also for bringing the cuttings back to surface. So as we are drilling a well, we are constantly monitoring the mud, and that tells us about the formation itself. We also have the ability to rotary core, which is basically sending down a hollow pipe that cuts out a section, and we can bring the core of the ground back up. Wire lining, we'll take the drill string out of the hole and we will send in a wire with a probe, and the probe can do all kinds of stuff. It can do core sampling, seismic work, infrared, thermal imagery. It's a fabulous tool. Measuring while drilling and logging while drilling. The chemists and geologists are on board, and all the samples that are coming up through the cuttings, they're all doing that. And then the cutting evaluation itself, so you're expecting certain layers. So when you're doing a drill plan, there'll be, I don't know, they'll say there'll be 200 feet of this and 500 feet of this. And as you're drilling, all those cuttings that you're cutting through come to the surface, and they measure that as well. So they have a really good idea when they're drilling of what to expect, when to see it, and so forth and so on. And we'll get into that more when we talk about the drilling sections. Well, folks, that's the end of section 3. I hope you enjoyed that. Take it easy and have a great week.